All right. Hello and welcome everyone. Good morning, good afternoon, good evening, wherever you are in the world. Thank you so much for joining us today. My name is Sarah Alspaugh. I will be your webinar host coming to you live from Cincinnati, Ohio, here in the US. I'd like to welcome you to today's webinar. Our topic, Accelerate Product Development with PLM Integrated MBSE Software. And I would like to welcome and introduce our speaker today. With us, we have Mark Sampson. I will briefly read from his bio here and then turn things over. Mark Sampson is the product evangelist for integrating systems engineering and requirements within the Siemens Digital Industries Software Product Lifecycle Management business. After graduating with a BS in Computer Engineering from BYU and an MS in Systems Engineering from USC, Mark started his career at Texas Instruments, eventually ending up at Siemens with a breadth of 30 years experience around applying systems engineering tools in a variety of industries and well-known brands: high-tech, automotive, defense, aero, medical devices, consumer products, and others. Mark is INCOSE MBSE Initiative Chair and member of Technical Board overseeing scaling systems engineering efforts in data exchange and system modeling standards. All right, well, welcome, Mark. We're very excited to have you here today. I'll go ahead and pass things over to you and let you take it away.
Thank you, Sarah. She said I had 30 years experience. I know I don't look that old. I graduated from college when I was 12 years old. How's that? So let's go ahead and get on here with our presentation. We're here to talk to you about a communication problem that you guys have in product development. You already know about this failure to communicate across domains, which accounts for many of the costly mistakes and that you're experiencing, which makes program execution so hard. We're labeling it start integrated, stay integrated, but the idea here is that we can't afford to spend half our program schedules anymore spending our time on finding these problems late in the product development process. So we're talking about it as a continuous integration or continuous communication to help you accelerate this product development process. So to give you a little background on this, when I was a teenager, my grandmother was visiting us, and she's a well-known philosopher in our family. Apparently wasn't moving fast enough for her, and she pointed out to me that she said, Mark, you know there's a difference between jogging and being chased by bears. She's absolutely correct. There's a difference. So let's talk about a few of the bears. In the aerospace business, you guys are probably already aware of this. Norm Augustine, that's the legendary CEO of Lockheed Martin that has all his laws. If you guys want a good read, go look up his laws. I think you get them at Wikipedia and other places. But number 16 is that we're going to reach the point we can no longer afford to make airplanes at the rate we're going. He has recognized this, and they've joined up in a consortium called the Aerospace Vehicle Systems Institute. This AVSI is located out of Texas A&M University. The idea is they would want to get together to figure out how they could make quality products at affordable prices. Among other things, there's a number of projects that are being run by them. One is called System Architecture Virtual Integration, in which they've been gathering various measurements or metrics on complexity in aircraft. You can see this one they're looking at is source lines of code. You can see what it's doing, and according to using Barry Beam's software economics, he says that we've reached the level of unaffordability on these airplanes. And so that's the outcome of this consortium is they're making some advice to the airframers and others that you have to change the way you're doing business. You can no longer go along the line of spec, design, and then integrate. You've got to integrate and then design, as they put it, or you have to start integrated, stay integrated. That requires a different way of doing it. They've recently added to this list their military aircraft as well, which bears this out as being even worse. Of course, the reason we're having these problems is because as you look at your systems development process, in this case 4754, you can see the silos showing up as we move through this process from left to right. And these silos, of course, gather artifacts, and these artifacts are maintained in a variety of different places, a variety of different databases, a variety of different documents, and so forth and so on. So as you look around here, you can see, for example, the requirements are maintained someplace outside or different than where the architecture is maintained, the targets, the test cases, the compliance documents, the list goes on all the way to the right. running action item lists, manufacturing plans, and so forth. That means that we shouldn't be surprised when we read the right-hand side that when something changed on the left-hand side, like a requirement, we're testing the wrong thing or vice versa. Of course, what this means is we're not discovering the problems till we get to integration on the far right side here. And that means we've lost. There is no place for us to maintain the voice of the customer. There is no single source of truth. Any lessons we've learned along the way are maybe caught, but generally they're able because they're in people's heads and we could potentially reason them that way. But otherwise, we lose them. And of course, we don't have the benefit of any cross-domain, cross-silo traceability or change impact. The result is we cross our fingers and hope we've got it all. The result, of course, of all this is that you're going to spend half your program schedule and resources dealing with these integration problems late in the product development process. Of course, what that does is it delays your time to market, and for your suppliers, it delays your time to revenue. Of course, as you look at this makes perfect sense to us as you're looking at the various tools that we use, the various silos that are out there with mechanical, electrical, software, so forth and so on. And notice that it kind of funnels to the right in the development process where we periodically go and see if we can get this stuff to integrate. And so integration itself has essentially become its own silo. And of course, what's going on here is that we have not only those, we have many other domains and disciplines that are going on here, maintenance and safety and test and security and materials and regulations and reliability, the list goes on here. And of course, what you guys are doing here is that as you're not communicating across these domains, across these silos, you'd end up discovering these problems late in the development process on the integration side and so forth. Now, of course, what you guys have done is you all bought into PLM as a general rule, product lifecycle management. I work with Teamcenter as a PLM solution. And of course, what its business in the business of doing is managing all these diverse product data, wherever it is, and managing the change and the workflows and the variation and all the other kinds of things that go along with it. What we're proposing is that we're talking about expanding the relationships available in PLM and to take that integration that you just saw as a separate silo off to one side and actually integrating it with the product lifecycle so that we're continuously integrating all along the way. And we're going to do that by including requirements and the product architecture and the functions, parameters, simulation models, and so forth in that same place as the rest of the product information. And by doing that, we're enabling this idea of continuous integration rather than waiting too late in the product lifecycle to discover the problem. Now, in order to pull that off, we got to be following a process, a systems development process. Many of you are familiar with systems engineering or in COSI, the International Council of Systems Engineers and others. So if you look at their handbook and other places or the various ISO standards, for example, ISO 15288 or IEEE 1220 or the other ones standards that are out there, they all start on this far left at the system of system level, where you're after trying to understand all the stuff outside your quote unquote system, trying to understand the interactions with the outside world, just like the airplane isn't just an airplane, it has to interact with the air traffic system, the airspace, airports, maintenance systems, and so forth and so on. So the idea here is you start at the far left, trying to understand all the constraints, all the interactions of the outside world, getting them captured and understood. And then, of course, what you do is you start developing the use cases and demands based on those interactions and constraints that you have. And then you step into that and you start looking at the requirements, a selected set of requirements that are going to be development process that are going to tell you when you're done. As you choose that, as you step into this selected product requirements, you move into the conceptual design part of the problem. We're after looking at as many what ifs as we possibly can to make sure we got the most robust architecture solution that we can come up with. And then from there, you start looking at how we're going to go about doing things. You step into the system design, driving system requirements, and move into the system design part of the problem, which then leads eventually to the electrical, mechanical, software, and so forth and so on, which of course leads into CAD systems. And then you start developing the BOM systems like your bill of materials or your product structures. And of course, from there, you move into as built, as maintained, as manufactured, so forth and so on. So that process, moving from left to right, describes the systems development process that is encapsulated in not only the standards, but in things like, for example, the system engineering handbooks and so forth that you're trying to manage and do. We're going to focus our efforts on is up here at the far left of the process. Let me see if my marker is working here. Here we go. Up here on the far left of this product development process. This is what's critical because what happens here is this is where we establish the threads that run through things and where we establish how things are going to interact and communicate with each other, like, for example, mechanical, electrical, software to electrical, and so forth and so on, reliability. Now, of course, we have tools that step in here and support this process. Like, for example, you're familiar with the CAD world, the NX world, and the mechanical world, the Mentor tools, and the AA world, and so forth and so on. Manufacturing processes are maintained in Teamcenter quality. And of course, you have the SimCenter capabilities, which stretch from not only the design part of it, the optimization, but also helping you explore the envelopes of the front end of the development process. And of course, Teamcenter is here supporting this entire process because it's needed to maintain these digital threads through configuration and change and workflow and so forth and so on. But what we're going to talk about here is up here the product development process, product definition, the front end that needs to be done. Now, this stuff is equivalent, that goes up here is equivalent to what the architects do to build a building in the form of a blueprint, for example. You would never expect the downstream development people, like, for example, the mechanical engineers or the software or the elevators or the parking guy, to make their designs or structures, to make their designs, unless they're all working from the same set of blueprints. And so that's what we're talking about here, is in this product definition process is where we develop the blueprints for our product development process. So let's step in. So now that we understand this process, let's take a step back about why it is we should want to integrate MBSE with the product lifecycle. As Sarah mentioned, I'm the chair of the INCOSE MBSE initiative. When we first started down this path, when I first joined INCOSE 15, 20 years ago now, we recognized that this organization, this discipline was very document oriented in the form of specifications and so forth. And we realized if we're going to scale these systems that are coming at us, which include millions of requirements, millions of interactions, and so forth, we're going to have to move to models. We're going to have to go to a higher level of abstraction, including models. And we started down this path of this model-based systems engineering approach. We decided that we needed to help us with that culture shift inside the professional society, that we needed a story that we could tell that would help people see the value of the vision of what we're talking about with integrated MBSE. So I'm going to share that with you to get everybody on the same page. I know it's not an airplane, but I think we chose this because we wanted to be generic enough that anybody could understand the value here. So if I had an integrated MBSE capability, and let's say, for example, I received a regulatory change for a requirement. Say, for example, emergency braking distance was going to have to change because of some issue. And in your organizations, someone asks a question like that, we're going to change the braking distance, let's say, from 110 feet to 90 feet. That would typically launch a trade study, which would lead to days, weeks, months, even years in some complex situations to understand what the potential impacts are. But because we've got this integrated MBSE solution, we can get some near real-time feedback from our solution, from our vehicle, that these areas of the vehicle are potentially impacted as a result of this change. So we step into that, and here we see, for example, 7 different models reporting in their perspective on the problem. At the 12 o'clock position, you can see that our hydraulic fluid is no longer compliant with the requirements. Okay, that was a fairly straightforward one. We would have probably assumed that our thermal models at the 3 o'clock position were probably going to have some issues. Okay, but as I wander around here, I begin to see the emergent behaviors that start to happen here. You can see, for example, our hydraulic pressure is fine, but for some reason our cruise control has thrown a fault. Our mean time between failure calculators tell us we got an hour at 3,000. We got a problem at 3,000 hours, and for some reason we've gone to 18 amps in our electrical circuit, so we could step into that, and we see we've blown a fuse, and we can follow that to the schematics, and from there to the harnesses. And here, for the first time, is when we see this relationship that we never knew existed before, that our customers would have discovered in their driveways at 3,000 hours. When that sensor failed short at 3,000 hours, it shorted and caused this cascading effect. So now we have a new hazard that we need to worry about. So we update our failure modes and effects analysis capability matrix and all the processes that go along with it. While we're here, we might as well go correct the MATLAB model that's causing our issue because the cruise control code is generated with MATLAB. And while we're here, we might as well look at the actuarial tables because we should be getting a better insurance rate, right? Because we're able to stop this vehicle faster. Now, the only way I'm going to be able to see this kind of combination is at a higher altitude to be able to look down the problem. And there's no one tool that's going to have this information. It's a combination. And these threads that run through all these different systems or different disciplines or different tools are going to need to be maintained, and the right place to maintain it is with the product lifecycle management. So it can be subject to configuration and change and everything else that goes along with it. And so that's what we're talking about, is integrating the MBSE systems engineering capabilities of requirements and parameters and system models and so forth as part of the product lifecycle. I want you to consider that vision that you just had, I just described to you, to how it's going on in organizations today. Now, I have the opportunity to visit many different industries and many different organizations, and I get some inside stories that you probably never hear because they never escaped. But in one place, for example, I went and visited a large automotive organization, and I got a chance to talk to various engineers. One engineer was telling me about her experience when she first joined the company. And she was talking about how they would move her around to place so she get the big picture of what's going on here. So she was saying that when she got to the warranty department and they handed her a problem, a customer problem, and the customer problem was water on the knee. So she got the car, she opened it up, looked at it, and she discovered what was going on. So as you look here at the speakers, you'll notice the wire harness comes out of the hinge point and comes down and gets on this. And so the idea here is because there's water inside the door, it's not watertight, water would be shaking around and get up on those wires, and you know what it's going to do. It's going to wander down here until it gets into the speaker. And as long as you're not running full bass, you're probably fine. But if you're running full bass, what's going on here is it's throwing water onto the passengers. As she looked at that wire harness, she decided that she noticed that there in the prior version of the wire, the harness had a wire loop in it. And of course, you know what that wire loop was doing. It's performing the function of keeping the passengers dry. The way it's doing that by carrying the water away from the speaker. Now, manufacturing people would come along and say, what's this extra 4 inches of wire doing here? Let's get rid of that so we can save ourselves, because we're talking about a lot of vehicles here. And so she saw what was happening was every 6 months, the wire loop would disappear, and then the problem would come back, and then they'd put the loop back in and go back and forth like that, back and forth. Now, you guys know the definition of sanity according to Einstein, which is doing the same thing over and over again, expecting a different outcome. And that's what's going on in many organizations, this kind of insane behavior. Once we discover a problem, we fix it, and then we discover that we've got some other problem, and we discover years later that it was already discovered, and then we just rediscovered the solution to it. This got us thinking a little bit about, I wonder how long does a problem once solved take to come back in other industries? We in our analysis, we found that it takes about 3 years in auto, which makes sense because that's about how long a lot of projects seem to be. High tech is running about 6 months. And then, of course, the aero, because you guys' projects are longer, about 15 years. So what we're talking about here is the type of insane behavior that's going on in organizations. We look closer at these problems because they're cross-domain problems. We find, of course, that they're the result of siloed and disconnected decisions. We found that these problems have this tendency to follow functions. Just as architects know form follows functions, or that's what they're taught, we believe that problems follow functions as well. And of course, you need to have everyone involved. If everyone's not involved, then you end up with some point of view not being understood, like purchasing, for example, needs to be involved in these decisions in some way. Then, of course, we have this idea of disconnected requirements, where requirements might be changed somewhere and not communicated to other places. We have this idea of uncommunicated change. These have this tendency to happen at the organizational and domain levels or boundaries. And of course, they seem to migrate with people because people are carrying the experience in their heads. And if they're not around to see the problem and recognize it and prevent it from happening again, then we have the problem come back. So it's both an overt, either it's there because you weren't there, or a covert, or it's something you didn't know about. So the idea here then is it's you guys got this problem with the fact that we wanted to get these ideas out of people's heads, these experiences, and get them someplace. And of course, it's also the result of missing or disconnected product architecture. And when I'm talking about product architecture, I'm not talking about the architecture that exists in your PowerPoint slides. You need to be somewhere so everybody can see it. Now, as you look at this list of things, these are suspicious given by system engineering training, are all the things that systems engineers are supposed to be doing. For example, they're supposed to be defining and managing the functions, the requirements, change, impact understanding, managing the interfaces, developing the architecture, so forth and so on. So this got us thinking about how we might predict or measure an organization's sanity, or just how sane are we. So as you look at column A here, This column represents the things that systems engineers are supposed to be doing per this discussion we just had. Like, for example, they're managing parameters and they're managing requirements and they're defining the requirements in the architecture, so forth and so on. So what we did is we put those things here, if you will, 15288 and other standards that are out there that describe what you're supposed to be doing here in this area. And then what we did is we said, well, these things could be done in a disconnected way on the far left, or they could be done in a continuous or a connected way on the far right. With the idea being on the far left are things like the document-oriented artifacts that you guys are used to, specs, interface documents, so forth and so on, in text form. On the far right, of course, is where our continuous or communication with models takes place. Now, remember, we said that we need to keep this continuous communication because we're spending half our program schedule late in the product development process discovering these problems, what are essentially the subject of missed communications that are going on between various disciplines, tools, and so forth. So let's give you an example here of how this works. So here in the requirement management, for example, you could be managing requirements in uncontrolled spreadsheets sitting on George's desk. You could be managing requirements in a document that might be in some kind of SharePoint repository. You could be managing requirements in one of the various thousands of standalone requirement solutions that are out there. But as you move from left to right here, as we move through this process of disconnected to connectedness, you want these requirements to show up places. For example, you'd like this requirement to show up inside a MATLAB model or inside a CAD model, for example. The best of all worlds, if you step over to the far right, would be these individual requirements. We're not managing requirements as documents anymore. We're managing individual requirements, whether they're models or text. And those individual requirements are then part of the product lifecycle such that when I set my product configuration, I'm also configuring my requirements. And because they're part of the product lifecycle, they can now be linked to things like, for example, to test cases, to tasks, or in program schedules, or to manufacturing processes. You get the idea here, and that's where we're beginning to get the value of requirements. Let's try one more on you. Interface management. We care about interfaces in systems engineering because that's where all the bad things in a product's life happen, or at these interfaces. Today, you could be managing those interfaces in documents. This is the most popular interface control document. It's got configuration control boards on it and so forth, change management on this document-oriented kind of a process. But as we move from left to right of disconnectedness to connectedness, you would want to start managing individual interfaces. You'd want to be in libraries for reusable interfaces and packaged up in such a way. The best of all worlds would be if we talk about the fact that if I've got a functional architecture and as I allocate functions to things that are going to perform those functions, I essentially define an interface. And then if I carry those functions throughout the entire product lifecycle, that means that as they carry through, they can show up places. Like, for example, I can ask a wire and a harness, what are you doing here? And it can tell me what function it's carrying, or I can ask a hydraulic line or pipe, what are you doing here? And it can tell me the functions it's performing. So that represents, if you will, the maturity of disconnectedness to connectedness as far as MBSE is concerned. Remember, we're trying to get to the right here. So what we've done is we've gone out into the world and we started talking to many different organizations, many different places, and many different industries. And this is the average organization. I'll let you look at this. What it says is that we're all acting insane, or we're predisposed to insane behavior, I'll put it that way. Discovering the same problem over and over again, etc. So as you look at this, by the way, this is an optimistic model. We asked people when they tell us, we're asking them to think about the best they've ever seen in their organizations. And what they've done is they're not thinking about any one project, they're thinking about their whole experience in an organization. And so this is what they see. Now what we've done, of course, is we've broken these out. So for example, this is the best we've ever seen in aero. This is the best we've ever seen in auto. Now, as you look at this, you expect a few things. For example, auto really cares a lot about variation. And so that's why they emphasize that point. That's why you see the highlight up there with variation. But because we've done enough of these and it's statistically significant, we can predict about you being about right here. And what we'll do is we'll make an option or offer to you guys as you go through this is we'd be glad to add your organization to this data. And the idea being, in exchange for your honest answers, we will send you back a curve of where you are, and then and along with a comparison of how you compare against others in your industry. Of course, this is all anonymous, of course. Now, as you look at this, the important aspect about this is that you're going to discover that model-based system engineering is a journey, right? So, for example, the tools and everything are working themselves to get up here at the top. And if, for example, Teamcenter today now has a functional architecture capability, and if we asked you to go up there and start doing functional architectures, and you're down here doing interface control documents, and we ask you to make this leap from interface control documents all the way up to functional architectures, culturally, that's just not possible. But we could say, let's take this interface control document and let's rip it, and let's get a bunch of interface elements that can be managed with a product lifecycle, so we get change and workflow and history and all the other kinds of things you'd care about. You can make that journey, you can make that leap, and you can start working on this journey from left to right. But before you start this journey, you need to understand where you are. So it turns out there's a whole bunch of, I guess the words target-rich environment. There's lots of places you can start with this effort, from moving yourself from left to right, from disconnectedness to connectedness. And remember, the reason we're doing this is because we're after getting rid of that half the time we spend discovering late in the product development process our integration problems. We're after discovering them early, doing them often and doing them once, so we don't have to keep rediscovering them. And then, of course, we're doing this because this is going to help us deliver the project on schedule, on time. It'll bring a whole new effort, whole new predictability to your project development process and execution program management. So here you can see 3 different areas that kind of stand out as common that we've run into, the areas that could be used. So for example, I'm guessing you guys, many of you are keeping your parameters inside of spreadsheets. We could have a conversation with you about how we move from managed spreadsheets by parameters part of the product lifecycle, so they're participating in the configuration change and can be reused across the organization, and so forth and so on. We could talk about using requirements by taking these requirements you currently have in your standalone solutions and coexisting them into Teamcenter so that they have the ability to participate in program schedules and product and change management and so forth and so on. You also notice right here, right below that is the verification and validation, which is currently done probably, I'm guessing, in a separate place than where your requirements are maintained, which of course allows us then to create some relationships directly between the requirements and the test cases. What we found today in many places we go is we find that you're over testing your organization. Since you don't have any visibility into where tests go, you're testing everything every time because you don't know where it goes. The result is we find that because there are 2 different places, almost a 25% of your requirements, because they're maintained in places other than test and vice versa, are not being tested. And we actually find about 30% of test cases are being overdone, have no reason to be tested. We could have another conversation about that if you guys would like to do that. And of course, up here at the top is another opportunity. As you're moving from PowerPoint and Visio into system models, we're after integrating the system architecture, system models, functional architectures, and so forth with the product lifecycle so we can see where things go per this vision. We're including, for example, the ability to take your system models and integrate them with Teamcenter if you're up that advanced. So I show this to you very quickly just to give you a sense of what we're talking about. And is it worth the journey? Well, let's give you a couple examples of where this is actually borne fruit. This is 787 back in 2011. One of our Boeing came and gave us a user group presentation on this topic. They used our prior generation of our product to do managing the interfaces across this entire aircraft. Some million plus interactions are going on across this, as you can imagine. All physically separated, triple redundant, that kind of stuff going on. So what they did is they captured this architecture functionally, and then what they did is start drawing interrelationships between things that were connected to each other, right? And now you see, as a result of those interactions, then they put this publish and subscribe system in place with our solutions. And what it did, when something changed, it was automatically communicated to everybody up and down the chains and demanded a response. They just couldn't let it go by. And you had to tell why or why not it wasn't affecting you, so forth and so on. So it puts you on the same page continuously. You also had the option of saying, hey, it'd be great if I had this, and you could push it back the other direction. What this enabled is a continuous communication that was going on across the entire life cycle of the project. You see the quote here from the chief engineer on 787. They showed this graph in their presentation. This mauve color that you see here is 777. And you can see the 777 had some 16,000 squawks or integration problems at first flight. They said that accounted for 1.5 years of the program schedule. It delayed program by 1.5 years. What you see here below with all the zeros is 787. 787 delivered 0 squawks on first flight because they were continuously integrated. More modern version of this is the Boeing TX example. You can see here the quote from their program, the chief engineer, first 14 flights without pilot squawk. These are powerful statements that talk about the value of staying continuously integrated and not discovering the problems late in the product development process. So what we're talking about here is this whole product development process. We've been focusing up here at the front end of the product definition and how critical it is that you get this captured inside of the PLM so it can drive these cross-domain digital threads that you guys are currently dealing with and where all the problems happen in the late product development process. By doing this and by participating in the product lifecycle, we can now help you prevent these kinds of problems, give you confidence in your ability to do so. We've been around enough of these that we're beginning to give you some advice on how to best make this transition. We talked about this idea that it's not going to be, this is a journey. It's not something you just flip a switch. We think the best place to start would be getting your requirements under control, getting them into PLM so they can now participate in impact understanding change and help enable a more agile development process. And then, of course, from there, you're going to begin asking the questions about where do these requirements come from, and you begin to get the architecture involved in there and enable that as part of the product lifecycle. And then as you move to the right, you begin to share these architectures using team center capabilities, like, for example, supplier collaboration and others. Share these with suppliers in such a way that you're bringing the suppliers into this continuous integration effort, as well as a continuous verification and validation that's going on. So when a change takes place, you're able to continuously V&V this thing as you go along in this process, and eventually get into this whole digital twin, cross-domain digital twin that allows for this continuous integration in a very real sense. And of course, as you move up from level 1, level 2, level 3, and level 4, we're here to help you along the way, and I hope will give us the chance to do so. So with that, I'm going to go ahead and open for questions. Sarah, I guess.
All right. Thank you so much, Mark. And this officially concludes today's webinar. Thank you so much for joining us, everyone, and have a great rest of your day.